One of the things that we have to also draw as a conclusion from different molecules that are said to be polarized, that their relative electrical positive or electrical negative charge on a different part of the molecule could be something that is very interestingly keeping these molecules together, as you and I can see from the example of this picture, which illustrates type of bonds that are called hydrogen bonds. So you can see here that these five different molecules are all built the same. They represent five molecules of water. And we know due to different distribution of the electrical charge, it is part where the oxygen is, which has more electrical negativity, where hydrogen atoms of the molecule are exposed. These parts of the molecule are having more electrical positive charge. So, as the positives and negatives are attracting to each other, this molecule of water with its more positively charged end will become equally attractive to this molecule of water with its electrically negative end, which is where the oxygen is. Same thing will happen between centrally positioned molecule and one on the top, as well as between the centrally positioned molecules in these two that are at the lower part of the diagram. So these are known as the hydrogen bonds, and practically they become cohesive factors such as, for example, illustrating why the water molecules stay together. Why, when we spill the glass of water on a horizontal surface, yes, some of these hydrogen bonds will be broken because the water could be spilled over a wider surface. But essentially, you would still be able to see individual droplets of water that are composed of millions of molecules, and the hydrogen bonds between them practically prevented their separation. Apply this to greater volume of water like ocean. It is essentially also what prevents ocean and rivers and lakes from getting rid of their own fluid, because that water is held together. So we have something that is cohesive factor here and prevents that large volumes of fluid filled compartments. Like inside the body, it's going to be intracellular compartments, so practically inside of each and every cell is made of water, but also the outside of the cell, so-called the extracellular compartment, also is not allowed to dissipate and to lose the integrity between different water molecules it must have.